Scott's Geography Notebook.
Da, da, da.
We're going to talk about the metric system a little bit. And what I really am kind of doing is helping out those of us that grew up here in the United States. If you grew up here in the United States, we grew up using a different unit of measurement. If you grew up somewhere else, you're probably having an advantage in your science class. But for those of us that grew up here in the United States, we have used all sorts of strange units of measurements. Right? So we have, for volume, we have things like how much space something will take up. We have weird things like a teaspoon. Now, I look in my drawer of all my silverware, and I've got like 4 different sizes of teaspoons. That's okay. I've got just as many tablespoons. And at some point, we decided what a cup would be equal to. And that cup, from there, we just built on from there to a quart. And that quart, there's times 4 of those equals a gallon. Right? And so all of these different units of volume, we use them all the time in our kitchens here in the US. The other thing that is kind of strange is going to be weight. And weight here, we have ounces. An ounce, OZ, right? And then they do something weird, right? So what you'll see sometimes on your sports bottle or whatever you're drinking, sometimes they have fluid ounces, right? So what's a fluid ounce? I have no idea. Is it the weight? Is it the volume? Right? So that's a good question. Now, we have our ounces, and let's see, there should be 16 ounces is equal to 1 pound. Now, for my English friends, this has nothing to do with your pound. Maybe at some point it did, but no, there's going to be 16 ounces a pound, unless you're talking about silver or gold. In that case, it is a troy ounce, not a toy ounce, a troy ounce, and there are 12 ounces equals 1 pound. And I always wonder, like, is that pound less or these ounces more? I don't know, right? So we're going to have ounces and we have pounds. Distance, we do some crazy weird things as well. Right? So remember these guys, we were kind of just like, oh, commonly used will be this teaspoon. And that's the problem with a lot of these. They're just commonly used, right? So we're going to be using an inch. That's going to be 1 unit. And I think that someone decided, probably nobility, decided that they were going to use their finger length or their thumb length for that. Okay, 1 inch. And if you times that by 12, then you get 1 foot. Okay. Whose foot? I don't know. Okay, so is it a foot? And then we have 5,280 feet equals 1 mile, but that has nothing to do really with each other. 1 mile is equal to old military 1,000 paces. Right? It's going to be 1 mile. These guys are kind of crazy, a little difficult, and there's no relationship among them. So let's take a look at the metric system. During the French Revolution, the common people decided to come up with a unit of measurement that didn't have to do with the thumb length of nobility, didn't have to do with the length of someone's foot. Okay? And what they started with is my favorite subject, is the earth. Okay? Now, they, let's see, over here in France, they understood the curvature of the earth. They knew the distance from pole to the equator. Right? And they took that distance from the pole to the equator and they came up with a meter. So the distance from the pole to the equator, whatever that distance is, let's divide it by 10 million, and that is going to be 10 million meters. Now, a meter, for those of you, again, here in the United States, that's going to be 1 meter is approximately 39 inches. So a little bit bigger than a yard. Don't get me started on yards. Okay, so that's going to be, that unit of measurement is going to be, for distance, it's going to be meter. Okay? Now, here's the other nice thing that they really helped us out with our conversions. If you remember back over here, we were looking at times 12, times 5280. 3 teaspoons makes a tablespoon. 16 tablespoons makes a cup. It's crazy, right? So what they did for this particular system is everything is base 10. Okay, so let's talk about what this idea of base 10 means. It means that you can go higher or smaller. You can make it times 10 or divide by 10 based on, and that will give you a different proximity, right? So if you were to take 1 meter times 1,000, you would give a little prefix of kilo. Right? Now, I'm going to just leave it blank right there. I'm not going to say kilometer because they use the same thing for their units of weight for all of them, right? For all of the different units of distance and weight and volume, all of them we're going to be using the same ones. Now, if you want to go smaller, you can. You can divide by 100, and that's going to give us our prefix of centi. Okay, how many cents to a dollar? 100, right? So a cent a dollar would be 1 cent. I don't use dollars. But anyway, you get the idea. Now, are there other ones, right? Could you times 10, times 100, times 1,000? Yes, but these are the more common ones that we use. If you were to divide by 1,000, then that would be a mille. Right? So a millimeter, a centimeter. Now, a centimeter, I know we're going back to our fingers, but the height of a pinky, that's about a centimeter. If we really want to go technical, a centimeter is from there to there, right? That's going to be 1 centimeter. Right? Cool. My ruler, which is 12 inches, sorry, it's going to be about, it's a 30.5 centimeters. Good. Okay, so we've got that figured out. Now, for volume, they did something similar using the same measurement, okay? So what they did is they went with this centimeter. If we could take that same distance and draw a little block, 1 centimeter, by 1 centimeter by 1 centimeter. 1 centimeter high, 1 centimeter wide, 1 centimeter deep, right? And we would call this 1 centimeter cubed, but the volume of that is equal to 1 milliliter. Milliliter. 1 milliliter. Okay, now that's kind of small, but if we take 1,000 of these, milliliters, good. ML is going to be the abbreviation we'll use for that. 1 milliliter is equal to 1 liter, and I just happen to have 1 liter nearby. This guy right here is my water bottle. It holds 1 liter of water. You can see the little milliliter measurements along the edge there. So that's going to be 1 liter. Right? And then we have weight associated with these guys as well. Okay? So here's what we do. We're going to grab this same guy, this 1 cubic centimeter, right? And we're going to put it on the scale. 0, 1. And if we take that cube and we put our little cube on that scale, 1 centimeter cubed, or 1 milliliter, right? Or sometimes in the medical profession, they say 1 cc, right? All of those guys, 1 cubic centimeter, milliliter, 1 cubic 1 cc, perfect. All of those guys, they have a weight, if it were water. H2O. If it were water, the weight of 1 cubic centimeter of water is equal to 1 gram. Okay? 1 gram is very, very small. Okay? For those of you, again, here in the US, 1 penny, I believe, is going to be about 4 grams. Right? So a gram is going to be very, very small. Just picturing that tiny little cube of water that's there. It's not that much. Right? What we commonly will see, again, is we'll go bigger, times 1,000. That's going to be equal to a kilogram. And you know what weighs a kilogram? Well, I'll show you. A liter of water weighs 1 kilogram. Right? So a lot of the Nalgene bottles that you can get are going to be about this same. If you're used to buying the recyclable bottles, those usually sometimes are 500 milliliters. Right? So they're going to be about half of a liter, right? Or they're going to be weighing about 500 grams or half of a kilogram. Good. Okay, one other thing that I do want to talk about is energy. And so this is going to be weight. And then I also want to talk about energy. Now, energy is all related to this as well, right? So first we want to talk about temperature. Okay, temperature has a range in the metric system as well. It's going to be in Celsius. Okay. And really, really nice, thank you very much, water. Water, they used the freezing point and the boiling point at sea level for water. So water freezes at 0 degrees Celsius. And water evaporates or boils at 100 degrees Celsius. Okay, love it. 0 to 100. Okay? For those of you here in the States, we have these kind of bizarre numbers of 32 degrees Fahrenheit and 212 degrees Fahrenheit for that number. Why? I just don't know. 0 to 100, it's a beautiful little straight line. Room temperature is going to be at about 21 to 22 degrees Celsius. All right, that's about 72 degrees. Cool. Now, one other thing that I do want to talk about. We're talking about temperature. We're talking about water. In order to change the temperature of 1 milliliter of water, if we wanted to increase the temp of 1 milliliter of water by 1 degree Celsius, okay, that is going to require 1 unit of energy. And that unit of energy is called a calorie. 1 calorie. Now, we have calories in our food. The food calories are called kilocalories, but usually we just refer to them as calories. Same idea, except every 1 calorie in that bowl of ice cream is actually equal to 1,000 of these. That's a kilocalorie. Okay, so if you want to raise the temperature of 1 milliliter or 1 cubic centimeter or 1 centimeter cubic cc, right, by 1 degree Celsius, between 0 and 100, then you need to add 1 calorie.